In this example, I have a couple of zeros of a polynomial equation. Zeros are solutions, places where it hits the x-intercept at. So I finished the problem and I found out that the zeros are -3, 2, and 5. We can work our way backwards and find out what polynomial did they come from. Well, if we remember, these guys came from some factors of the polynomial. So it's going to be f of x equals a, where there's always a little bit of a coefficient up front. This first factor was an x plus a 3. The next one is an x minus a 2, and then x minus a 5. And I hope that makes sense a little bit, because remember, if we took each of one of these guys, in order for this to equal 0, one of these factors has to be 0. So we set each factor to 0 to find out what its solution is. So x plus 3 equals 0, x had to be -3. And so I did that likewise with all of those. I'm also going to just the polynomial I'm going to find, there's lots of them that have these solutions, so I'm just going to use one that has a 1 right there, just to kind of clean it up a little bit. And I can go a little bit further. I can multiply all these guys out. So f of x equals x squared minus 2x plus x minus 6. That's the first two times each other, times an x minus a 5. And now I need to multiply the x minus 5 through. I like stacking them on top of each other. That's a little bit helpful for me. So x squared plus x minus 6, x minus 5. 30, -5x, -5x squared, skip a spot, -6x, x squared, x cubed. So x cubed minus 4x squared minus 11x plus 30. That is one polynomial that has three solutions that are -3, 2, and 5. And again, those are the x-intercepts. Last thing maybe, again, this is my preference on how I multiply factors times each other. I like to stack them on top. Maybe you like to stick them next to each other and do lots of these types of things. Make sure you have multiplied everything. Whatever works for you, keep it going. Make sure it works for you and keep practicing them.